Assalamu alaikum guys. Up till now we have seen the basic analysis, the modeling techniques and the design of this basic simple steel structure based on gravity loading. And we already know that steel connections play a very vital role. But I'm not going to cover the connection details or the connection design in this lecture. But we are going to see that how to alter or model based on different connections. Before going any further, we know that there are two types of connections, the moment and the shear connections. Here are a few examples of moment connections, where the flange as well as the web of the rafter is connected to the column flange, and these are a few examples of shear connections where either only the web or some part of flange is connected to the column flange. So we know that in moment connection, as clear by the name, there will be moment resistance at this end of the beam, and this connection will transfer that negative moment to the column. Whereas in case of shear connection, there will be no moment transfer to the column and the member will rotate at this end and it will not resist any moment. So that shear connection will only resist the shear forces. And we know that in moment connection, if there is negative moment, definitely the positive bending moment will reduce and it will result in lighter section as compared to this connection. It might be the case that the member sections are increased in case of shear connections. So let's get to our model. We will check and discuss both the type of connections. I will just make a replicate of this model, Control R on the keyboard, and I will replicate it at 20 meters in the y direction. Okay, let us hide these purlins and area sections so we can clearly see that what impact different connections are bringing to our model. Okay, so now let's run the analysis and check the moment diagram by pressing F8 on the keyboard. Here I will select my moment M3 and click on apply. Now it is evident that the member, these rafters are resisting both the positive as well as the negative moment at the support location. So there is some negative bending moment value, which means that by default the connection is fixed connection between the rafter and the column. But now if I want to change my connection to the shear connection and I want to make this moment as 0, so I need to alter a few parameters. So let us unlock the model and select all the rafters, go to assign frame and releases / partial fixity. Now here you can see all these options are unchecked. So this start indicates that the I end of the member and end indicates the J end or the J node of the member. So I want to make my moment 0 at both these locations, so I will just release my moment at these two locations, the start and the end of these rafters. Let's click on apply. Now to check if the option has been applied or not, I will go to general options, click on standard view. Now this indicates that some property has been released. It can be either axial, shear or moment, whatever the case might be. So if you want to make this visible, you can always press Ctrl W on your keyboard, and under the heading of frames you can check this option. Okay, now if I again run the analysis and now compare the moment diagram of both these frames, now it is clearly evident that there is only positive moment in these beams, and since there is no negative moment, so the beam is not transferring that moment to the column. Therefore there is no moment in the column as well in this direction. Now if we compare the values of both these models, here it is showing around 130 kilonewton meter moment, whereas in the fixed connection or in the moment connection it is showing around 78. So means there is a lot of difference between these two values. That is why these sections might be heavier as compared to these. Let us run the design and check what impact does it bring. Control Shift F5 to display the utilization ratios. Okay, here we can see that these two members are now failing. Utilization is 1.61. Previously it was 0.975 in case of moment connection. Now we have two options here. We can either increase the member section and reduce this utilization ratio, or we can we can modify some other factors. But before that we need to check whether our deflection is in the limiting range or not. So I will select the service load combination and click on use Z here for global Z deflection. Click on apply, and I will change my units to millimeter. Now for a better view I will just turn on this extrude option. Now here we can see that in the minimum value is 40 millimeter. So in this structure these beams are deflecting at around 40 millimeter, whereas in this one with fixed moment connections they are around like somewhere between 18 to 21 millimeter, and the limiting value is span divided by 240, which means the span of this beam was 10 meter, so 10,000 divided by 240 is 41.66. so this value of 40 is just below 41, so we can say that our structure is safe and we do not need to increase the member sizes in this case. So what we can do is there is one option here. We have already discussed about the unbraced length, and in our case the unbraced length ratio for all these rafters was 1. So if I press F4 and see the undeformed shape, all these rafters are having unbraced length ratio as 1. So there is one detail, I'm sure you must have seen it somewhere in steel structures, that if this is your main rafter, this is the purling running over it, and this is the bracing member which is connecting the bottom flange to the purlin. So this bottom flange is braced against any lateral movement. This purlin, this might not be the case that we need to provide this at every purlin, but this might be provided at adjacent purlins, or after every 2 or 3 purlins we need to provide this bracing member based on the design. So to incorporate that, what we will do is we are going to change the unbraced length ratio. So since we assigned our purlin at every 1 meter, so after 3 purlins from this side and 3 purlins from this side, and there will be 4 meters of distance in the center. So I'm going to select my members and I'm going to change the unbraced length ratio to 4 divided by 10, which is equal to 0.4. So let's unlock the model, go to design, steel frame design, view revise overrides. Here we already input as 1, so we are going to change it 0.4 and 0.4. Click on OK, and now again run the analysis shift F5 for the design. Now we can see that the utilization has decreased considerably from 1.6 to 0.78. So this means that by bracing our members we can reduce the utilization ratio. Even in this structure with the moment connection we can provide the bracing. So since the deflection was within the limits, so we only needed to adjust a few parameters. So now the detail is going to be that we are going to provide this bottom flange bracing at every 3 meter at the edges and 4 meters at the central location. I hope you have understood the concept of these shear and moment connections, and now you know that how can we make the connection between column and rafter as shear connection, and the connection between columns and rafter as moment connection. If you have any questions you can always ask me in the comments. I will be happy to respond. And we are going to discuss the connections, the design of connections in the next lecture inshallah. So till then, take care, and Allah Hafiz.